Hello, hi guys. Happy Tuesday. All right, how you guys doing? This is our October week 2. Any of you had your finals already? Or you are having your finals right now? Dying. Let me, you're always dying. When are you ever not dying? Okay, so are you guys ready? Shall we do some revision today? See, Terence, that's the spirit, doing good. See? That's good. Terence, I assume you are having your finals right now, right? Have you had your science paper? Oh, tomorrow science, I see. Okay. Okay, cool. Wow, just in time, huh? Okay, so any else of you having your science paper soon this week? Any of you having it soon? Okay, shall we do some exercise today? Shall we do some exercise today? Okay, since some of you are having your finals, right? Let's do some chemistry revision today, shall we? Okay. Terence, do you need chemistry or do you need physics? I'll give you a choice here. Do you need chemistry or do you need physics? Anyone else? Anyone else needs physics or chemistry? Because we are still. Oh yeah, have you guys received your October notes already? This one, the one we were doing last week. Do you guys have this? You should have it by now, guys. Yes, Ingwei, hello. Why you suddenly? Why you suddenly say hi to me? Any of you guys cannot hear me? Cannot hear me? Okay, can you hear me now? Yes. Terence, since just now you can hear me? Is it? Because my setting here has nothing wrong. Everyone can hear me? You could. But suddenly cut off. Even now? Just a moment, guys. Testing. Okay, guys, can you hear me right now? I already cranked the volume to the max. Can you guys hear me? Too loud. Oops. Sorry. Okay. Is this better? Is this better? Yinghui, can you hear me? Yinghui, can you hear me? Do you guys have this note with you? You do? Yinghui, are you okay? Lemin, can you hear me? Chloe, can you hear me? Just to make sure. That's weird. Why some of you cannot hear me? Yes, huh? Okay, good. Lemin, can you hear me, Lemin? Yeah. Okay. Yeah, fair enough. Okay, so guys, shall we do some revision? Shall we do some revision? Any of you have any requests? Any of you have any requests? Which chapter you want to do? Which exercise you want to do? Or you want to do chemistry or physics? Because if not, I'm just going to continue with chemistry. Okay, guys, can I let you do something? Okay, instead of me giving you the answer straight, why not you do something for me? Okay, so guys, can you please continue with question 4? All right, because I realized that throughout our year, I haven't let you do any exercise, on the spot. So why not you do some? Okay, can you please try number 4 and number 5 and number 6? Okay, shall we do question? You know what? We skip 6. We skip 6. We do 7 instead. Okay, 4, 5, 7. Can you please do 4, 5, 7? I'll give you 15 minutes. Please make it quick. Okay, I'll give you 15 minutes and we will discuss. Shall we? Shall we? Okay, I'll let you do. Guys, I'll let you do. I'll give you 15 minutes. I'll be back in 15 to discuss this with you. Okay, is everyone okay? Is everyone okay? Okay, so question 4, 5, 7. All right, you may begin right now. Okay, I'll see you in 15. If you have anything to ask, please let me know in the chat. I'll reply you in the chat. Okay, feel free to ask. Don't be shy. Okay, 15. All right, hi guys. Are you done? Should be quick questions. Yes. The rest of you? Anyone haven't done yet? Lamin, how are you doing? Are you okay? Okay, cool. Chloe, are you done? Jingen, are you done? Okay, I'll give the answer. I'll give the answer. If you remember this question, this is your reactivity question. Okay, from the most handsome guy to the least handsome guy. Remember, the taller the guy is, the more handsome he is. Okay, so you look at the observation, you know. So powder P has been heated in continuous oxygen flow. So this guy is marrying oxygen. So this is what we see. Okay, so when you burn P is glowing with bright light. Okay, glow, that means no fire, it only glows. Q glows with dim light. R burns, there's a fire with a very bright light. S burns with a bright light. Guys, who is the most handsome guy here? Which reaction is the biggest? Who is the most handsome guy here? And who's the least handsome? Who's the shortest and ugliest guy here? Can anyone tell me this first? You're not answering the questions first, I'm making you understand first. Who is the most handsome guy here? Anyone? P? Are you sure? YP. YP. Do you think glow or burn is the biggest? Most. Yes, it's R. So R is the most handsome guy because you see, burns, there's a fire, there's a very bright light. Okay, oxygen is very excited to marry him because he's very good looking. What about the ugliest guy here? Yes, Q. So you see, when oxygen marries Q, it's very not exciting. So it only glows with a dim light. It's like, okay, whereas R is whoa, big fire. Okay, so one method to produce oxygen in this experiment, we will use something called potassium manganate 7. Okay, I'm not sure whether I've mentioned this before. Potassium manganate 7 is a purple colored crystal, or potassium permanganate. This thing will produce oxygen for you. And guys, this is very flammable. This thing is very reactive because oxygen is reactive. So this thing produces oxygen. It makes this thing very easy to catch fire and explode. Okay, so arrange P, Q, R, S in descending order. Guys, in descending order, should you put the handsomest or the ugliest guy first? Descending. What does it mean by descending? Is it less to more good looking or more to less good looking? Who should we put first? Guys, this is math. Descending. Who is descending? What is descending? Anyone? Anyone? What's the meaning of descending? Or you can just tell me the answer if it's easy for you. Who is at the box number 1? Yes, it's going down. So who's at box number 1? Okay, we start with. Are you sure? Yes, we start with R. Yes. Okay, we start with the most handsome first. So we start from the tall one, then we go to the short one. Okay, followed by S, followed by P, followed by Q. Okay. So Terence, the one is ascending. So yes, Jian, you're correct. Jian, you're correct. Yes. Okay, so guys, don't get the sequence wrong. It's very not worth it if you get this wrong. Okay, descending from the most handsome, the tallest to the shortest. Okay, name a possible metal for R. What do you think R is? Which metal is this good looking? What do we burn? Did you guys do this experiment in school? Did you guys do this in school? Yes. So what is that? What is that? Oh no, some of you know. Okay, what is that metal that gets you the biggest flame? Yes, it's magnesium. Did this hurt your eye? When I taught this, you haven't done this experiment, isn't it? That time, few months ago when I taught this. And then did it hurt your eye when you saw it? I told you. I told you don't look at don't look at magnesium with your naked eyes. It's gonna hurt you. It's like a strong camera flash. I said so, huh? Yes, that's right. Okay. I learned it the hard way too. Right? Because my teacher said don't look at it with your naked eye, it's going to hurt you. I was like, yeah, me. I don't believe you. And then, oh shit, it really is. Okay, so that's a magnesium. Next, does the mixture of metal R and oxide S react when heated? Explain the answer. Okay, guys. Metal R and S oxide, when they add together, what's going to happen? This is the Rampas girlfriend story. Remember? I take away his girlfriend story. Remember? Okay, guys, who is married now? R or S? This is what I call displacement. Okay, S is married, right? Because S oxide. Oxygen is married to S. Okay, so guys, who is more good looking? Who is more handsome? R or S? R, right? Girls, if you're married to a guy that's not so good looking and a good looking guy come for you, what would you do? What would you do? What would the girl do if a more handsome guy comes for her? Let me know. Okay, what would you do? Okay, oxide will follow R away. Remember this story, guys? This is the displacement reaction. The good-looking guy will displace the ugly-looking guy. Okay? In water also same one. Zinc plus copper sulfate. The copper will get kicked out, and then zinc will react with the sulfate. Remember? So R will take S wife away. Okay, R will take S wife away. So now S has no more wife, because kena rampas already, ma. Okay, so yes. Okay, in this case, we say displace, all right, because R displaces S. Okay, because R is more reactive than S. Okay, like I said, reactive means good looking. Okay, R is taller and more good looking than S, so reactive. Yes, metal displacement, that's correct. So R displaces S. R kicks S away. Okay, because S ugly, R good looking, so R will get the girl. Okay, so guys, the other way around, if it's R oxide and S, do you think S can displace R? Do you think S can displace R? Do you think S can kick R away? Can S kick R away? Anyone? Can S kick R away? No. Okay, because S is uglier. Okay, you're the uglier guy, you cannot kick. Yes, more. You should be less reactive. Okay, S is less reactive, S is less good looking. So S cannot kick R away. Okay, so next, number 5. Same thing. Okay, so guys, who's married here? Who's married here? Copper. Okay, but who is more good looking? Copper or aluminum? Yes, alu. So what will aluminum do? Aluminum will kick copper away. Okay, and then aluminum will get the girl. Copper will be kicked out into the water, so you start seeing copper. You will start to see this aluminum disappear. This aluminum will start to become smaller piece. And then you will start to see copper will drop down here. Copper is being kicked out. Aluminum is getting the girl. So aluminum gets less. Am I making sense here, guys? Am I making sense here? So you see, aluminum and copper sulfate are now aluminum sulfate and copper. See, the copper got kicked away. So now copper is left alone. No, this is not rust. Rust is iron. Rust is iron. What is this reaction called? Okay, it's called displacement. Okay, why? Because aluminum displaces copper. Okay, or you can say a more reactive metal displaces a less reactive metal. Okay, something like that. A good-looking guy will kick away the ugly guy. Okay, that's what it means. Next, C. Ali then places aluminum in a solution of lead nitrate. Write the word equation for this reaction. Okay, can aluminum kick lead away? Yes. Okay, so you have aluminum and lead nitrate. You will get aluminum nitrate and lead. Okay, so now the lead got kicked away. So number D. He then places some copper into a solution of sodium chloride. Would that be a reaction? Can copper kick sodium away? No. Reason? Because it is less reactive. Good. Okay, because copper is less good looking than sodium. Okay, copper is less good looking than sodium. So cannot kick off. Cannot kick off. There's nothing that can do. Okay. Should we discuss number 6? Guys, do you still remember the 3 methods? Yes, I think it's more reactive. Yes. Do you remember the 3 ways of producing salt? Okay. And what is it? What is it? Evaporating. No. Chemically. Chemically. Okay. What is it? You have metal plus acid. Good. This is method number 1. What else? That one actually got answer already. Okay. It's metal. Sorry. It's carbonate plus acid. Okay. Metal oxide plus acid can, but not all oxide is soluble lah. Can also. Precipitation. No, Terence, that is physically. I want chemically. And of course, the last one, it's neutralization. Remember? Acid plus alkali, you get salt and water. Okay. And then you see the name got already. Acid plus carbonate. This is acid plus metal. This one. Acid plus metal. This one. This alkali plus acid. This one. Okay, so name the salt form. You will get calcium sulfate here. Okay. Why is it physics always fail? Okay, so aluminium nitrate. Okay, this will get potassium chloride. And this one is sodium chloride. What's with physics? What's wrong with physics? Physics has done nothing wrong. Physics is innocent. Okay, so next. Diagram shows experiment to study the effect of size of marble on the rate of reaction. Ooh, guys, rate of reaction is for sure coming up for exam. So pay attention here. So the experiment is repeated by replacing marble chips with marble powder. Okay, so one I use marble chip, one I use marble powder, and I add acid here. Which do you think is faster? Powder, good. Powder. Guys, what factor is this? No, it's not space. Close. What factor is this? It's the what of particle? More space to vary. No, 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 no. Further, no, 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 no. Guys, those are form one. Sorry, those are year 7, year 8. Okay, between marble and chip, it's about the size, right? Size of particle. The smaller the size, the higher the rate of reaction. Okay, yes, it's about the size. Okay, so as you can see here, for marble powder, 60 seconds, this guy already collected 15. Whereas this one needs 150 seconds. You see the difference? Because chips are so much bigger. So state the responding variable. Guys, what's the responding variable here? What are you trying to observe here? Usually when you see a table, for sure you will get the variables here already. Okay, so that will be your volume of gas. Okay, this is your RV. Guys, okay, this one they didn't ask, but I'm asking you, what about the MV? What is the manipulated variable here? What am I trying to control here? You see, I observe the volume, right? What are we trying to control? What are we manipulating? What are we controlling? We are controlling the chips and powder, right? The size of marble, yes. Not size of chip, size of marble, because one is chip, one is powder, man. The size of marble. Okay, this is your MV. What about your CV? What about your constant variable? What are you not changing here? Guys, there are 4 factors to rate of reaction, right? If you are changing one, the other 3 all becomes CV. Okay, volume of acid, I accept. Everything else becomes CV. Amount of water, a bit unrelated though. I mean, can lah, but it's a bit unrelated. What else? What else? Guys, there's so many answers. Mass of marble, yes, can. Guys, you can even see temperature. I need the same temperature. If not, it will be different rate of reaction, right? We're only changing size here. Marble, the temperature. The 4 factors lah. Okay, the 4 factors. What else? About the acid one, what is the reactant? The amount of reactant. You can even say, guys, concentration of acid. Because both acid needs to be the same concentration. If not, how to do the experiment? Right? Okay, relationship between size and volume. This one just give me the relationship. Just give me the what do you call it? The hypothesis. The higher lower, or lower higher. What is it? Smaller, bigger, whatever. Bigger size, low volume. Yes, can. Or the smaller the size, the higher the volume. They go in opposite. Okay, because you see, smaller size, more gas. What do you mean can't remember? Okay, what is the factor that affects the rate of reaction? Okay, what factor is it? Okay, I just mentioned already. That's the size of reactant. Okay, size of reactant. Name the gas collected. What gas is here? Guys, marble is a carbonate. When you have carbonate, what gas is it? It's so straightforward, isn't it? Yes, you have your carbon dioxide. Okay, you have your carbon dioxide. Okay, so next. Okay, we have like 10 minutes left. Shall we do some physics? Shall I do some physics? Okay, can you please try question 1? Yeah. Can you try question 1? And 2. 1 and 2. See if you have enough time. See if we have enough time. I'll give you 5 minutes. 5 minutes. 1 and 2, huh? Okay, guys, we are running a bit out of time. So let's give the answer. Okay, so what is density? Guys, do you still remember what is density? What is the formula for density? Here comes physics. I mean, this is like your favorite part. So what's density, guys? Yes, mass per unit volume. Okay, mass per unit volume. Oh, hey, you see, you remember, not that bad. Okay, an object which is what will, then a liquid will float. What makes you float? Okay, when you're less dense. An iron nail sinks in water because its density is more than the density of water. We will say denser usually. An object that sinks can be made to float by. How do you make something float? Yes, you decrease its density. Okay, number 4. When two liquids that do not mix are placed in the same container, the what liquid will float? Okay, the less dense will float. Okay, easy peasy. Let's see if we can finish this by today. Okay, the rest of it we do it next week lah. Okay, measuring cylinder weighs 250 gram. Okay, so this is the mass. After 50 cm cube of liquid X is filled into it, the new mass becomes 300. So this is the volume. Okay, so guys, the mass of the liquid is 50. Because the beaker, the measuring cylinder is 250. I put water, it becomes 300. So the water itself is 50 lah. Okay, so this is the mass. What's the density? The density is mass divided by volume. So it's 1. Yeah, sure. Okay, you sure put it in, can? So 1 gram per cm cube. So obviously this is water. What could be liquid X? Okay, liquid X is water. Because water is the only thing that's 1. I mean, it could be 1 point something like if you put salt in it, like seawater. Seawater is like 1 point something. Guys, fun fact, you know what's human's density? You know what's human's density? Since you're 70% water, your density is pretty close to water. Human density is 1.08. 1.08, just ever so slightly denser than the seawater. That's why you sink. But not too quickly, but you're denser. So you sink. Right? So B, an iron ingot has the density of 19. What is the volume if it weighs 3.86 kg? Guys, can you see gram here? So you have to change the kg to gram. So this is 3,860 gram. Since we know density equals to mass divided by volume, this is the density, this is the mass, so we find the volume. So 19.3 equals to 3,860 over volume. Guys, at this point it's math already. So V equals to 3860 divided by 19.3. So what would be the answer? What would be the answer? 3860 divided by 19.3. Anyone? Yes, it's 200. Since it's cm cube here, so we use back cm cube. Okay, cm cube. Okay, next, C. How can mosquito larva in stagnant water be destroyed by applying concept of density? So how do you destroy lava? You put oil on it. Okay, so put oil in water. So oil is less dense and floats. Right, when you cover it with oil, mosquito larva cannot breathe, so they die. That's the concept behind it. Okay, guys, I think that's all for today. Okay, Terence, all the best in your finals tomorrow. Okay, who else is having their finals here? Anyone else? If not, then we will continue with revision next week. Don't worry. Next week this one will be doing revision, and after that you will go year 10 already, I think. Okay, so I'll see you next week, guys. Have a good one. Happy Tuesday, and see you soon. Take care. See you. Good night. Bye bye.